problems it's having. I don't know what to tell you. That's why the old ways are the better ways. The new ways are more expensive. Okay. Let's take a look here. Hopefully you guys notice this is back. So let me something that's not on there. Let me give you an example of something that'll help you out in this in general. If I have log base 7 of 6 plus 4 log base 7 of 6, if I have something plus 4 somethings, that means I have, if I have something, and then you bring 4 somethings, I have 5 somethings. So if I have one of these plus 4 of these, I now have 5 of those. Why am I allowed to add these together directly, just straight up add them? Because they're like terms. So logarithms don't suddenly go, I know about your like term shit, math, screw that. No, logs have to follow that freaking rule. That rule doesn't matter what the shit's going on. So I really want you to understand that I can straight up add them only if they are exactly the same base and thing on the inside. Then they are like terms. So why in the shit can I do this? Log base 7 of 6 plus log base 7 of 2. And I can actually do something because that's how logs work. They are powers. And powers have properties I can use. So can I add these straight up together? No, they're not like terms. But does the thing I'm looking at have a property that I can use? Yes. This would become what? Log base 7 of? Yes, 6 times 2, which is 12. So I didn't add these together. I really hope you understand. I rewrote this in a different way using the property of logs. Yes?
So log base 7 6 is the like term?
Up here.
Yeah.
Yeah, I have one of these plus 4 of these, so of course I have 5 of these.
Okay.
That's independent of what these are. Right?
So if there was no 5, it would be 2 log base 7 6?
Yeah, if there was no 4,
Yeah.
then it would be 2 log base 7 to 6. Yeah. Then I have
Still
to
be at 36.
Hell no. No. Which one? Up here?
Yeah.
Okay. All right. If I have log base 7 to 6. Now watch. I really want you to follow this line. Log base 7 to 6. There are 2 main ways you can do this. 2 main ways. You can realize that these are like terms. So here's one way you can do this. One way. You can say, okay, that's 2 log base 7 to 6. Now, can somebody help me out? Where could I put this if I wanted to? And I love something like, I'll tell you where you can put that. Where could I put that? I could put it back up here, which is log base 7 of 30 frickin' 6. Yes, right? It's because the other way I could have done this from the beginning, the other way was to say I have log base 7. I'm adding them, so 6 times 6, 36. Both ways I do it better come out the same, or else all the math is shit. We can throw it out and go home. Too bad for you work, right? So there's always more than one way to look at something, but every way you look at it needs to come out the same at the end. Up here, why didn't that happen? Because I didn't use the addition property of logs. I didn't. I just added like terms. That's all I did. Now watch. Now watch. Has everybody got this here? If you wanted it. Okay. Now watch. I want to look at this a different way. Couldn't I put that 5 back up? Make this log base 7 of 6 to the 5th. Is that cool? That's that power property right? It goes back up. Now watch. Let's look at this a different way. Isn't this log base 7 of 6 plus log base 7 of 6 to the 4th? What do I do with when I'm adding like base logs? What do? Log base 7 of 6 times. And what is 6 times 6 to the 4th? 6 to the same stupid answer, right? I mean, of course, especially with logarithms, there's going to be multiple ways to put it together. Somebody wants to do this first, somebody else wants to do this first. You're going to end up in the same place at the end anyway.
And so you did that one differently
Just because. Just to
So
show you there's a different way.
that's the
So-
other example you gave us. It feels like you solved it differently. Like you did, but I feel like is the instruction the same? Like you're adding them.
All right, so this one, I don't have to use the property of logarithms on this one. I could if I wanted to. But since they are like terms, I could actually just do like terms. That's a more fundamental idea. That's like, that like terms is like, I'm always here whenever you want me, man. You got same shit, I can put them together. But if I choose to do it this way, it better come out to be the same answer if I choose to do it this way. This way is like terms, which is always true. This way is if there are logarithms with the same base, I could do this.
And how would you check that? Like, if you got 5 log 7 to 6, how would you check that to go into log 7 to 6?
What's happening? So, look, that answer and that answer, are they the same?
Yeah.
Yes, there you go. So I checked it. I get the same answer both ways. So if I have a problem like you guys saw on your sheets, if I had log base 2 of w plus log base 2 of y, can I do it this way? Can I do it this way? Because they are not like terms. I only have one real option. Use a property of logarithms. Why did I have more options here? Because they are, not only are they like base logs, but they're also like terms completely, because the 6's are the same too. So I had 2 ways I could do it. They just better end up at the same place. Or else one of them is wrong at least. Okay, baby. So I just wanted to point out, we are not, on that sheet, I don't think I put like terms anywhere. They're all just focusing on the properties of logarithms. If I did have like terms, you could totally do that all day long. Yes?
Could we leave the answer as the first one since it kind of basically means the same thing? Or we have to go...
If it says condense it down to a single log, this is 5 logs.
Oh,
So once you raise it up, now it's log. It's 1 log of shit, right? This is like 5 logs. That's why you do take that next step, bringing stuff, the coefficients come up as powers. So then you have 1 logarithm. I like it. Get all your logs together, Summer. Put it in the backpack. Okay. So what would this be real quick, since I wrote it up here?
Y times W.
All right, cool. Whichever way you want to put it. I like it. Like base logs, I can multiply them because they're adding. Multiply the insides.
So for number 3, here in the back, you would multiply 3 and 2, and that would be 6 log A, right?
Number 3.
Yeah. On the
Oh,
back.
well, let's get there.
Yeah.
All right, that's the last one. Let's get there. Okay, let's do these. And then I'll give you the answer key for the practice test, and we'll do whatever other stuff you want to do. Get ready for that test. Let's see. Whoop. So this first couple should be relatively easy. I know some of you guys felt gypped or something that there's really nothing you do with it, but you should really be happy. There's one step here. How do I break this up? It says use this to write as a sum of logs. So how do I break this up?
Log base 3, 7 plus log base 3x.
And can I simplify either one of these? The answer is no, so I stop. I don't know 3 to what power 7. Do you know that? No, somewhere between 1 and 2, because it's somewhere between 3 and 9, but that's the best I can do. And then this one is, I just want to show you that it doesn't matter how much is inside here. This would be log base A of B plus log base A of C plus log base A of D. Schwa. And none of them you can do. If one of these was A, I could have done that further. But none of them are. I can't simplify any of them. That's it. I did what the thing told me to, and I can't do anything else. I stop. So what about number 3? This is going the other way. This should be relatively simple, hopefully.
Log base 15.
So log base 4 of 15. I like it. Can somebody estimate the answer to this? If that was a what, this would be easy. If that was only a 16, if that was a 16, the answer would be 2. That's a little less than 16, so the answers are a little less than 2. So if I had to guess, I'd say 1.95, just to sound all technical. People go, oh my God, Jeff, you're right. And that's just because I did that shit. Oh, man. Now, I snuck this one on here. I just want... There's one root that we don't have to write the number in there, and we just know what it is. And, of course, that's what root? What root do we not have a number in there, but we know what it means? The square root. There's a 2 understood to be in there. Why do we do that shit? Because it's the most used root. Math people are infamously lazy. We don't like... They're like, let's save a lot of time over your lifetime. I'm going to write this stupid symbol a lot because I'm in math. Instead, let's just not write the 2, and we'll all go, we know what that one is. You're all cool with that now. You just accept it. You didn't even think about it really until I just said that. So when you see a log with no base, it's understood to be base 10, probably because our number system is based on 10, because we have 10 fingers. If we had 8 fingers, we'd have a very different number base. We wouldn't have the number 9. Anyway, don't think about that too much. So this is the one that's used in Richter scale. This is the one that's used in decibels. Richter scale is, of course, if you live in California, you should know. What is Richter scale? Maybe you don't know. Shit. It measures the strength of earthquakes. Okay. I've only, I don't say that. I was about to say I've only experienced 2 of those, and that's enough. People freaked out a little bit about this here, but that's just the number. That's minus 3. What do I do when I add logs to the same base? I multiply stuff on the inside, so I'm going to get x squared minus 3x. Now this is very, very different from this. These are 2 completely different things. This is the log of this. This is the log of x squared minus 3x. So here the minus 3x is not in the log. You've got to put the parentheses to capture it.
Well,
Yes, sir.
What if we did log 10? Log base 10?
Sure. You just don't write it. It's sort of like if you did this to me, I'm like, wait, we don't do that.
Yeah.
It's technically not wrong, but at the same time, it's conventionally incorrect. Okay, I'm not as concerned about conventionally, right? But I would put a little note. You don't need to put that. Okay, I like it. Any questions so far? Okay. So 5 is the quotient rule stuff. So this one I can do something with a little bit. How do I rewrite that? Now these are not like terms, right? So you can't do that. But what is log base 5 and 25? 2. Okay. And then 6 is a little quicker. I'm going to write the question. It's log base A of S minus log base A of T. So when you're dividing, you end up subtracting the power, so that becomes subtraction of 2 logs. 7's going the other way. So this would be log base 8 of, now look how evil I am. Your brain is going, 10 minus 2 is 8, and then you can do it. But what do you do when you subtract 2 logs? It's log of the quotient. So this is log base 8 of 5, which you can't do shit with. So you're done.
That was a
You
trick
can't.
question?
Huh?
Was that a trick question?
Definitely not, because it's the same property. So it might be me being nice to you and putting that on here, so you realize, don't look at the numbers to tell you what to do. Look at the setup to tell you what to do. 2 log subtracting, that's going to be the division. Don't let your brain go, 10 minus 2 is 8, that's fantastic. Say, who gives a shit, brain? I got to do 10 divided by 2. Well, do right, brain. So then number 8 is a lot like the other one we did, but there's even less to do. This would be log base 2 of x plus 2. And there's nothing you can do there, so you stop. Please don't kill those x's. All right. And then 9. How do you rewrite 9? Yeah, the 4 comes down. 4 log base 3 of x. You're done. I love how some of you guys are like, that's it? That's all I have to do? Oh, and you're angry. I'm like, what? You hate when there's multiple steps, and you hate when there's one step. I don't know what you should do. So just, accept it all. Since logs are related to powers, root form sucks. Anytime you have a root inside of a log, you rewrite it. For some reason, a lot of us forgot this, but what is the square root of x? How can I rewrite that? X to the
1/2.
It makes total sense because square roots cut things in half. Cube root would be, so what's the cube root of z? You can rewrite that as z to the 1/3, and then what happens?
1/3.
The 1/3 comes down. Cool. I like it. So 11 is just kind of doing that in reverse. Eleven is, there's a 1/2 out there. Where does it want to go?
Back to the 9.
Back up on here. And of course, what is 9 to the 1/2?
3.
Tree.
Oh, that's what it is.
Should be 50. Is that cool? Okay. And 12. 2 log b of x. What happens to the 2? Just goes back up, so you get log base b of x squared. The 2 just goes back up. And now finally, the last ones. These are the funky ones. These ones that have multiple things happening. So I want to give you a section where you can just focus on the product and on each rule by themselves, and now here's just everything can happen. So like 1 down there says log a x squared, and I'm going to rewrite square root of y in the better form. You guys start to see why I hate root form? You almost always have to change it. For most problems, you have to change it to power form anyway.
Too long.
Is that the final answer?
No. That's just what I'm going to write down so I can work with it now. Right? When you see a root, you write that as a power, and then you start the problem. So now we're going to start the problem. What's the main thing happening in here? Multiplication. Good. So it's log a of this times log a of this times this. How can I rewrite that? It'd be log a of x squared plus log a. And so what's the last thing I can do?
Power 2 log.
Take that down. Take that down. So 2 log a x plus 1/2 log a y. So that's completely torn back apart. Yes?
So we can't keep the exponents up there?
I mean, you technically could, but this is completely tearing it down to just its base form, right? Freezer. And, oh, here we go. And then 2 log This is going to be nifty. I want to show you a few different ways to think about this one. What's the only piece of that that's being divided? What's the only thing that's divided? Z squared. So that's the only part that's going to have a minus on it. So how can I write this? The main thing happening here is the division. You see that? It's this thing divided by this thing. So I can rewrite that log base b of this stuff. When I divide two things, how can I rewrite it? Minus log b of this stuff. See how that's a minus because it was on the bottom. And then you can start ripping things apart. Log b y. Can you guys handle this? This is going to be log b with w cubed. The 3 comes down. And then here the 2 comes down. Do you see how, if I rewrote this, you don't have to do this, but if I did, do you see if I brought that back up, won't it be a -2 now? And then I could just do log base b of y, log base b of w cubed, log base b of z -2. The -2 comes down, see? Same damn thing. Doesn't matter how you rewrite it, doesn't matter what order you do things in, you got to end up in the same place. So that's why that one's negative. It says it would have a negative power if you brought it up. Which is another way of looking why division becomes a minus. Okay, and then, let's see. Number 3 is just what we did in reverse. We're going to put stuff back together. This is the one that feels more like, this is the one we do most often. What does math try to do? Put stuff together. All right, so this is the one that we do more often. Where'd you go? 3. Now, to make sure you really understand why we do this first step, I don't have a property anywhere that says 3 logs plus 2 logs. I don't have any property that says that kind of shit. So what's in my way are those stupid coefficients. Thank God I can get them out. So that's what the first thing you do is you bring coefficients up as powers. Get them the hell out the way. If I had log A plus log A stuff, I could do something. I don't have that. Shit, let me get that thing out of the way. So this is log A 3 cubed plus, yeah, that 2 just goes back up. And now I can write this as log A. What is 3 cubed? 27. No C shift.
X squared.
X squared. Sweet. Evolution. So what about this one? So what's the first thing you have to do?
Set it up in division.
Move the.
Can't set up a division yet because I don't have log minus log. I have log minus 2. Oh, shit. I really want you guys, we have a property for log minus log. Don't we have a property for that? It's not what this says. Stupid 2's in the way. That's why you always get that out the way.
So not -2, just 2.
You could take the -2 up, and then that leaves a plus here. Either way you do it, you're going to get the same thing. It's going to end up on the bottom. I kind of prefer to just bring the 2 up.
Yeah.
Minus log base A, x plus 5 squared. So then this would be log base A. Let's go ahead and factor this while we do this, right? We know we're going to have to simplify in the end anyway.
Yes.
So that's going to be x plus 5, x minus 5. All over x plus 5 square. So what happens there on the inside? One of the x plus 5's cancel. So I'm left with log base A of x minus 5 over x plus 5. Oh my God. Why do you torture us, Jeff? You signed up for it. I'm just doing what you want. Let me give you the answer key for that practice test. That's right. I'm here for you. Coffee? Sorry, I can't do that. I had some, I drink. Yesterday. Anybody else need a blank copy of that?
Part of it, I stopped to figure out,
That's all right.
This was wrong because
Oh, see now look. This would mean that everything in here was being cubed. Only the W is being cubed.
So rewriting for
The
myself like
thing
this.
inside the law,
you're wasting your time if you don't.
yeah.
So they're being multiplied. So
If you take a
add.
3 down, you're saying the whole thing is being raised to the third power. That's not true. So you have to first break those two up with addition.
So like, okay, gotcha. So it, okay. Thank you.
Sure.
Like there's a program that I should go to.
All right, guys. So it's wide open. Look at number 7. I started doing the first problem. I was like, oh yeah, we haven't done it. So those will be on the next test. Let me see. Anything else? Anywhere it's got, look at number 4, for example. Now we understand that's a base 10 there, but I still won't give that to you on the actual test because we haven't done that real section yet. And then number 3 especially, don't worry about. That symbol ln really just means log base e. And we haven't even talked about what the hell e is. E is like pi, and we're not going to worry about it yet.
So we're not going to see that.
Don't worry about e yet. Say again?
We're not going to see that on the test.
No. You will see problems like that, but I'll give it to you like a to the 7th equals w. Rewrite that. I like it. Just there, I want you to realize ln means log base e. E is a special number like pi is a special number. We'll talk about those later.
You did this on the board already, so can you go over it again? On the composition and converse practice sheet, it's graphed the function of 3 with the exponent x minus 1 plus 2. I just wasn't really getting the x row, the 3 row and how it correlates to x.
All right, so watch. If I had, so for f of x equals 3 to the x minus 1 plus 2, the base function, taking away all the movements, is 3 to the x.
Right.
Which means my base function looks like this. 1/3 there, 1 there, and 3 there. That's my base function.
Why?
If, huh? What do you mean, why? All right, 3 to the 0 is? 3 to the 0 is 1. 3 to the first power is 3. 3 to the negative 1 is 1/3. You can always get those 3 points. Those are my anchor points. Those are the points I'm going to pick up and move. So if instead it was 4 to the x plus 1 minus 5, what would the base function be? 4 to the x. And then my anchor points would be 0 goes to 1. 4 to the 0 is 1. 4 to the negative 1 is 1/4. 4 to the first power is 4. See how that point's going to be higher than that point. So if the base was 100, the 1 would go to 100. Holy shit, it would grow very fast.
Okay. And then the negative 1 is the slope. Is part of the slope. Is part of
No.
how it moves.
No, yeah, part of how it moves.
Right.
So to do this problem out, I would graph, like it did, I'd graph the, what do you go, plus 2. So negative 1, 1/3, 0, 1, 1, 3 for plugging those in. There's my base, and then I would move it. So every point I would move, so this point I would move right 1 up 2, right 1 up 2, bam. This point, right 1 up 2, bam. This point, right 1 up 1, 2, bam. And I notice that my asymptote goes up 2 also. Everything goes up 2. So now now it looks like this. That's the beauty. That's how we developed the vertex form of a quadratic. We realized it was just moving 0, 0, moving that around. So how would I do this one? Here's the base function. How would it move? Yep, good. To the left 1, down 5. So I move every point to the left 1, down 1, 2, 3, 4, 5. So right about there, bam. That's going to be where the asymptote is now, because the asymptote is going to move down 5. I'm going to take that one and do what? Back 1, down 1, 2, 3, 4, 5. This one, back 1, down 1, 2, 3, 4, 5. And now there's my whee. How would I check that? Besides putting in the graphic counter. If I put a 0 into that, can you see what's supposed to come out? For an x of 0, where's the point? For an x of 0, where's the point? -1. So when I plug a 0 in, it better be -1 or all this is shit. So how do you always check a graphical answer to something? You plug points in and make sure they work, right? So this goes through the point 0, -1. So if I put a 0 in, what do I get? 4 to the 0 plus 1 is 4 to the first is 4, minus 5, -1. Hey, that's exactly what I thought it should be. Fantastic. That's how I can check it. Make sure. Again, what's the relationship between the graph of something and the function? Every point the graph goes through has to work in the function, so I can check it. Yes?
So for on a test, what would be the instruction? I would just tell you to
I would say to make sure you know to do it this way, I'd say graph this using the base function and the shifts. Yeah, shifts to back 1, down 5. Yes, you'd have 1 is the base function, the easy one, and the other one just pick it up and move it.
And my question, it might be obvious, why is it negative moves right and positive moves left?
So we've talked about that before. Like here, watch. How do I what do I make x? How can I make the output 1? What do I make x to make the output of this 1? 4 to what is 1? 4 to the 0. So x equals 0. So look at this. 4 to the x plus 1. What do I make x so the output is 1? 4 to the 0 plus 1 is 4. No. What do I make x so the output is 1? So what does this exponent have to be? It has to be 0, so x has to be -1. All my inputs have to be 1 less than they used to be, because what's the first thing I do to them? Add 1 to them. So the whole thing moves back. I really want that to make sense. It really is what makes this 0, that's how much it moves, in the direction it moves. What makes x plus 1 0? -1. Oh, it goes back 1. So if I had x plus 7, what makes that 0? Oh, it's going to move back 7. I love it. Yes?
Number 12 on practice test.
Okay. So this one, we've actually seen a couple that are like that one. So you're going to use the back wall of your house. Here's your house. Found your house. Here's your house. It's calling me. And I'm going to, now, so on top of that, my little green house, I'm going to make this rectangular area like that. Play area for your dogs. No, on the test I'd say rectangular. So use one side of it is your house, so you don't have to put anything down for that. So the 36 feet of fencing that I have is going to go into making these 3 sides. How long is this side?
I don't know.
Beautiful, so it's x. Which means this side has to be x. And this side, no, it doesn't have to be a square. It's just something else I don't know. Right. This I don't know, that's the same as that thing I don't know, that's could be different. Oh shit, so I better give it a different letter. Now in the work I might find out they're equal, but I don't know that right now. So what do they tell me? 36 feet of fencing, I like it. How does that translate into, how does all this translate into an equation? Careful, careful.
2x.
Because you're not multiplying, you're adding. 2x, two of these lines to construct, plus that one is going to come from my 36 feet of fencing. And what do they ask me about? Physically, what do they ask me
What is the
about?
largest area?
Area. Now what's the area formula for this shape?
A equals xy.
xy. And then how can you use what they tell you in what they ask?
Get y by itself.
Yeah, so I can get y by itself here, y equals 36 minus 2x, and I can throw that in right there. I end up with a quadratic, and it's going to add, it's asking for the max area, it's going to occur at the, where's the maximum happen? At the point otherwise known as the, what is that point right there? That's the vertex.
Vertex.
Okay.
What's the fast way to find the vertex?
The
Minus
axis.
b.
Negative b over 2a. That finds the x piece. So that's where I got negative 2x. I plug that in there and then multiply it out. I get my quadratic. Find the vertex. That's going to maximize or minimize it if it was an up parabola, right? Yep.
For the 9 when it's just, it doesn't have a shift, what do you do? Like if it was just 4x minus 5? Or does it always have a...
Oh, no. So if it was just 4 to the x minus 5, I would not have moved them back 1.
So you just
I would have
put it
just
down
taken this
5?
and moved it down 5. So if it was just that, I would have just moved everything back 1, and then that would be the answer. If it was just that, I would have just moved everything down 5. That would be the answer. This would just happen to have not only a down, but also a back. And if you go to take pre-calculus, you also learn how to reflect things, how to stretch them, how to compress them. We're just dealing with picking them up and moving them around, right? Yeah.
He was playing over 9
Now there I wanted to show you another option. So there I went ahead and make an XY table. I didn't tell you you had to use base function, right? So just to show you, if I don't say, you could do the table way if you want to. And then it said, use that to graph H inverse. Well, if I give you a graph, or in this case, you give yourself a graph, how do I graph the inverse of that? What do I do with every point?
Just flip it.
Flip it, and then graph the new point. And that's the inverse graph. So that's how I got that. So H of x is that one that's like this. Well, for you guys, like this. And then H inverse is the one that goes like that. That's the mirror image across y equals x. How did I get it? I just flipped all the points and replotted them. Yeah. Yeah. 13. So I don't tell you a way to find the vertex. Please, dear God, if I don't say you have to do it a certain way, you should do negative b over 2a. That's the shortcut, right? If I said, put this into right form using completing the square, oh shit, you got to do the completing the square to find the vertex. But here you can use x equal negative b over 2a. So what's the x piece of that vertex for x squared minus 6x plus 8? How do I find the x piece of the vertex?
What now?
How do I find the x piece? What's the shortcut?
So it'll be 6,
Yeah, negative b over 2a.
6 over
Yeah, good. Negative 6 is positive 6 over twice
1.
1. Understood 1 there.
Yeah.
So that is 3. How do I get the y? So that's the x piece of the vertex. Be careful. The vertex is a point. Don't get the x and stop. I love when it says, the vertex is 7. What does that mean? What do you... Don't tell me where it is. You got to give me the other piece. So how do I get that other piece?
Plug it in.
Yeah, y is going to be f at 3. Just plug a 3 in to see what the output is. So that's where I got the other piece of the vertex.
Which number is this?
The last one. Yeah.
Okay.
What's the y-intercept?
8.
8. 0, 8. Right?
Yeah.
And then, in this case, this was nice because it's factorable, so the x-intercepts are nice. Be really careful when I say find the vertex and intercepts. I mean x-intercepts and y-intercepts. Just find all the intercepts. Yes?
So you want axis of symmetry?
If I say so, you better put it down. What would the axis of symmetry be for this?
3.
X equals 3. The vertex is a point. The axis is a line. I need to see a line equation.
So on the test, you'll ask specifically, because here's the number 10, you said it, like how to compute the square, and then the quadratic.
Yeah, I could say that. Yeah.
Will you be specific?
Yeah, totally. Just the same way.
Okay.
If I'm not, if I just say solve this,
Right.
then you can use whatever method. Bless you. Yes, sir.
You don't need number 3, right?
Don't need who?
Number 3?
Number 3? Yeah, that's the one with natural log. But there will be one like that, but with a base we know. So if I said rewrite a to the b equals w, rewrite that in log form.
Okay.
Yeah. So you'll have a problem like that. It just won't involve e. We didn't quite make it to 12.5 yet, so I won't put any e or ln stuff on there.
Alright.
Yeah.
Sounds good. Let's make sure.
But you do have to know this general idea, right? This would be log base a
W.
of w equals b. A to the b is w, yay. You can always check it, because it's easier going the other way. Yes?
2A, how do you find the range of the...
Oh, okay. You need to know the basic shape of anything to the x power and log x, right? So the basic shape of a to the x is this, and the basic shape of log x is this. Right? So the mirror images of each other, right? Being very vague here. That is the shape of an exponential, and this is the shape of a logarithm. Okay. Meaning that unless a logarithm's been moved around, let me bring back in some specifics here. What is the domain of this? What x's am I not allowed to use for sure? Let's start that. Can't use negative, and I also can't use 0. Does it ever actually hit the y-axis? No, it's asymptotic. So in this case, the domain for that in general is 0 to infinity. You see how it's very related to, but not the same as, a square root. What's the domain of square root of x? What's the only difference there? What's the square root of 0?
0.
0. So I'm allowed to use 0. It can't be negative to stay real, so this would be 0 to infinity, including 0. This one can't include 0. Can't handle 0. I like it. So for the, just look at the log one first, since that's what I'm kind of doing here. Part B there. Oh, let's do this. Do you recall, how would I find the domain of this?
Greater than or equal to 0.
The square?
No. You're not allowed to do that shit.
Greater
You
than.
can't, so I don't like that function. Let me give myself another one. No. So you guys are trying to give a reason as to why the square root goes away, but it doesn't. What's the idea here? The inside has to be what? For this to work. Has to be
Greater than.
0 or more, right? It has to be at least 0. So the inside has to be greater than or equal to 0. Now, I didn't do something to this to make it become this. No. I used the idea. What's the idea? The inside has to be at least 0. That's what I write. I didn't get rid of the square root symbol. What's the only way that this could have a problem if the inside is the wrong thing? So that's, I'm focusing on the inside. And then I would solve this. So x greater than or equal to 3/4.
So in that, what would be the instruction to
Find the
solve?
domain.
Find the domain.
Yep. Not to solve. I'm not solving anything. I'm finding that guy's domain by writing what must be true. So what about this? What's the domain of this? Log base 7 of x plus 2. Well, what's got to be true? What did we just talk about? What's x plus 2 has to be... That is not a square root, guys. It's a log. Are logs allowed to use 0? No.
Oh,
That's
it
the
can't-
difference.
It can't equal to 0.
Logs are very similar to roots in a lot of ways, but they're not the same. Square roots are cool with 0. Logs cannot handle 0 or shit. So this has got to be greater than 0.
How come you didn't try to like solve the log first and then
All right, help me do that.
like how we were rewriting it? So like
So is there a product inside? Is there a division inside? No. So I can't, there's nothing that helps me in this. Do you see what I mean? There's no way to rewrite this. There's no property of log of the sum of something. No. If this was 2 times x, I could break it up as the sum of 2 logs. If it was 2 divided by x, I could break it up as the difference of 2 logs. But this is x plus 2. I ain't got no property for that.
I have a question.
Yeah.
Um,
Related to this one? Because
yeah, it is related to this. It's just a different way of looking at log. What does it mean by 1NE or LNE for log?
So that's what I was saying earlier. The ln of something is log base e. And e is a number like pi. It's just a special number that we gave a symbol to. It's a number that goes forever. So it's 2.71828, blah, 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 blah. And it comes out of a few different, like pi comes out of any circle. You take this distance and divide it by this distance, and you get the same number, and the freak's entire civilization's out. And now we're like, well, of course, because if it grows the same amount. Who gives a shit? But it's a special number. It's a special ratio. We gave it a letter pi. E comes out of some freaky-ass places, very surprising places. And so we're like, oh, shit, that's weird. Let's give that a symbol. Let's call it E. The guy who gave it the symbol, his name was Euler. E-U-L. But he didn't use E because of his last name. That was just the next letter he was using to do for all these things. It was a little side note. You know, great for
E is
Jeopardy.
2 point something.
2.71828, blah, 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 blah. Just like pi is 3.1415, blah, 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 blah. Yeah.
So,
You don't have to know that.
You don't have to know that for this next test. We haven't gotten to that section yet.
so
So the problems on the practice tests that
Yeah.
reference them, you don't have to worry about.
I just want to know how the LNE is like taken out and it's just 3P left. Like,
So help me out. Do you remember this problem we did earlier?
yes.
How'd that work?
We can sort of-
These
Yeah.
canceled. Why do those cancel? Because log base b and b to a power are inverses. So ln is log base e. So ln and e are inverses of each other. They kill each other. The answer there would be 8 also, for example.
Is it always going to be like that?
Yeah. If you cube root something cubed, is there any time they wouldn't kill each other? No.
No.
They will always kill each other. Why? Because that's their function. That's what they do. If cube root sees a cube, you're dead.
Okay.
Or a cube kills a cube root, they just kill each other.
Can we go back to this? I don't get, for 2A, which you asked about, I don't get how you got -8. I mean, negative infinity, positive infinity.
All right. So going back to this one, because you're right, I didn't really finish this one out. Do you see the shape of the log, right? Do you see it? How far down does this go?
Forever.
Okay, so the outputs go from negative infinity, and how far up does this go?
Forever.
Up to infinity. So the range of any logarithm, unless something really funky has happened to it, is negative infinity to infinity.
But what is the work for, like, I don't get.
There is no work, because you have to know what it looks like. That's it.
So just looking at f of x equals 2x plus 3, I should know that?
Where are we looking?
2A.
Well, 2a, the range isn't, the domain is negative infinity to infinity. That's the next, that's this guy, right? This guy here. And again, how far back does that go?
Forever.
And how far over does that go?
But I should just look at that and know that.
So,
What would be it, like,
so just because I put extra shit in here doesn't suddenly mean that x can only be certain things. X can still be anything it wants to be. What can I raise a to? Anything. So what if I add something to that? Well, still, it doesn't matter. I can still put anything I want to in there for x. I like it. So what's the domain of this? Infinity to infinity. I can put whatever the hell I want to in for x. There's no restrictions on this. How do I really know that? Because this is an exponential, and I know what exponentials look like. They cover the entire x-axis. So the domain is all real numbers, right? But what's the range? There's a floor for exponentials. There's somewhere that they go, oh, shit.
And that would be 11.
In this case, that's how much it went up by, right? That would be the minimum. So what would the range be for this? 11.28, oops, yeah. 11.28 to infinity. Because the asymptote would go how much? 11.28. The floor goes up to there. That must be the minimum now. So that's how I knew for part A that the range was 3 to infinity, because I added 3. I raised the floor up by 3.
And it's the same reasoning for 2B, except it's flipped because of this.
Yeah, exactly. It's a beautiful way to look at it. Logarithm is the